The modern software environment shifted at a whiplash pace. Type instructions into a prompt, and blocks of code materialize in an instant. Ask a tool to build a login form with validation, and you get a perfect script in seconds. Ask for styling, and the CSS appears right in front of you. For a beginner watching this happen, it feels exactly like magic. But then the dread sets in. They start wondering why they should spend late nights struggling to understand basic loops or data structures when the machine already knows the answer. That dread makes perfect sense. If the entire definition of coding is simply typing correct syntax, the computers have already won. That directly challenges how we have taught and valued tech education for decades. Look at the traditional junior developer path to see where this automation is hitting the labor market. The tedious, routine coding tasks at the very beginning of the pipeline are shrinking, actively absorbed by these tools. This creates a trap we call the beginner paradox. Junior developers historically needed those small, repetitive tasks to gain experience. But today, companies expect them to operate like mid-level developers from day one, equipped with an AI sidekick. The barrier to entry has moved. The interview question is no longer, "Can you write this code?" It is, "Can you supervise an AI's output, catch its subtle mistakes, and deploy it without causing a security disaster in production?" Labor market projections show strong demand for software roles, yet the entry-level requirements are shifting toward higher-order skills like risk assessment and architecture. To survive this shift, we have to split computer science into two distinct buckets: syntax, which is the physical typing and boilerplate, and systems, which handles architecture, security limits, and complex trade-offs. Large language models are extraordinary pattern matching engines. Because they train on millions of existing repositories, they excel at syntax, the well-defined, highly conventional parts of the job. But you have to treat them like a hyperactive intern who has read every textbook in existence and forgets nothing, but lacks all real-world context. They will happily assemble whatever you ask for without ever checking the blueprint. The moment you introduce ambiguous business requirements, legacy code bases, or high-stakes security rules, that pattern matching falls apart. The AI confidently hallucinates, producing code that looks professional but creates incredibly fragile structures. Automating the physical keystrokes of programming does not automate the actual science of computing. A mechanical excavator can dig a trench incredibly fast, but holding the levers does not make you a geologist. Let's test this with a realistic scenario. Imagine a computer science student building a simple revision planner application to track their modules, specific study topics, and daily study hours. Developer A takes the fastest route. They throw a simple, broad prompt at an AI, asking it to generate the entire app at once. In 5 minutes, they have a product that seems to work. But look closely at this calendar mockup to see the underlying failure. Because developer A did not specify constraints, the invisible logic is completely broken. The app silently allows overlapping deadlines and carelessly assigns 19 solid hours of studying to a single Tuesday until the schedule overflows. Now compare that to developer B. They act as an architect first, defining the data models, the specific edge cases, and the hard constraints, like a maximum of 12 study hours per day, long before they ever write a prompt. Instead of asking for a finished app, developer B asks the AI to propose a component structure. They use the tool to review their scheduling logic, explicitly asking it to find edge cases where the plan might fail, and to write tests preventing duplicate topics. The difference in the final result is extreme. Developer A outsourced the thinking and ended up with a fragile toy. Developer B used computer science fundamentals to supervise the machine, building a highly robust system. We are entering an environment where raw code is practically free to generate. When any tool can produce an infinite supply of a commodity like basic code, the market focus shifts. The value drains out of the production itself and moves toward the human judgment required to decide what should be built and whether the result is safe to use. Companies ultimately do not want coders. They want outcomes. They want systems that scale smoothly, keep customer data secure, and require a human being to take direct accountability when things inevitably break. A developer's professional value now scales with their ability to evaluate and take responsibility for machine-generated architecture. The period where basic syntax knowledge was enough to secure a high-paying career is ending, as employers raise the technical bar for entry-level roles. Computer science survives as a discipline of reasoning and systems design, even as AI automates the shallowest parts of programming. So you shouldn't quit your degree or abandon your learning just because an algorithm can write a decent login function. You have to learn computer science deeply, because when the code is entirely generated for you, you need the exact judgment required to know whether that code is brilliant or absolute garbage.